you will take the third exam on Friday, April 14th. This is a review for the exam. Let's try to solve some problems. Answer the assertions by yes or no for each of FG pairs under the given conditions. For relative rate of convergence or the growth, here we first measure the fraction f of g in modulus. Then as x approaches 0 or approaches to infinity or some number, here that can be bounded by m for a positive number m, or it can approach 0. In this case, we say that f is big O of g. And in this case, we say f is in little O of g. That's the definition. Okay, for these function pairs, number 1, number 2, number 3, and number 4. Okay, let's begin with the number 1. Now, f over g, okay, that is now here x over, now that is x minus 2023 over logarithm of x. Okay, now we can rewrite this one in this way. Here, x times logarithm x divided by x minus 2023. Right? Now, if x approaches 0, then top will approach 0, so that here we have limit 0. Okay, for this one, you learned this one earlier. Okay, now if we try to measure limit as x approaches 0, now x logarithm of x, then it can be written here logarithm of x over 1 over x. Right? Then if x approaches 0, then this approaches infinity and infinity, so that we can use the L'Hopital's rule, so the same limit, and top will be 1 of x in its derivative, and bottom will be minus 1 over x squared. So that term is same as now minus x. Right? So as x approaches 0, the value must be approaching 0. Right? So already you learned this one. So here, this fraction approaches 0 as x approaches 0. That means that here, now, okay, f is in little O of g. So here, that's yes. And once it is little of g, then now we can say this one is also bounded by some number, so that it's automatically yes. Right? Okay, here number 2. Now for fraction, here we write down here 1 minus cosine x and divide by here x squared. And for that one, now here, once x approaches 0, then it's approaching 0, and also bottom approaches 0, so that the limit can be here computed by using the L'Hopital's rule. So top will change it into now sine x, okay, sine x over now 2x. Again, one more time, it is approaching 0 and 0. So that one more time, if you take derivatives, then there is cosine x and bottom is 2. Now for that one, in modulus is bounded by here, okay, if we put every here now absolute sign, then this one is approaching to half. So we may say that this whole thing is bounded by 1, so it is playing the root of m. So that here now, the big O, that is yes. However, it is not converging to 0, so that it is no. Right? Okay, for the other two, you can do the same thing. Number 3, for that one, now top is arctangent, and so that this is arctangent of h, and bottom is h. And once h goes to 0, then this is again goes to 0 and 0. So you can take the derivative. So that is 1 over 1 plus h squared, and bottom is 1. Now bottom is 1. Now also top is approaching 1, so that is eventually approaching 1, but not approaching 0. So here the same way, this is yes, there is no. Oops, there is no. Right? That one should be no, right? And how about number 4? For this one, now same way, you start with the fraction. Now this time n approaches infinity, so we start with fn, that's n plus logarithm n, now cubed divided by n squared. Okay, for this one, that will be the same. Once you try to divide by n squared, then here bottom and top, then is same as now 1 over n, and plus here logarithm n here cubed over n squared. Now bottom and top simultaneously equals to infinity, so that you may take a L'Hopital's rule, but for that one is approaching 0. And here for this one, the same as 3 logarithm n, now squared and 1 over n, and bottom is the same as now 2n, so it is the same as now 3 over 2, the coefficients n here, okay, n squared on the bottom, and there's a logarithm n here squared. But we already know that, and log n and n is growing much faster as n approaches infinity, so that is approaching 0. Okay, it is approaching 0, so that that is in real law, and so automatically, okay, real law, so that is yes, so that here now for big O, we can say is automatically yes, right? Okay. Find the volume of the solid generated by revolving the region bounded above by y equal 2 cosine x and below by y equal sec x. Now x is moving from minus pi over 4 to pi over 4. This region is now rotated about x-axis, and the volume will be made, and we try to find the volume. 3 the solid is made, and we try to find the volume. Okay, now we have to understand the problem first, and here let's try to make a picture. Now from minus pi over 4 to pi over 4, the 2 cosine x is given now in this way. Now here, if you try to make sec x, then there's 1, and it is increasing that way, like that. So at these 2 points, they meet each other. This region, there's 1 and 2, and these are rotated about the x-axis, and this region will make a solid. Now we try to get the volume. The volume is the same as integral. Now the lower bound is minus pi over 4, and upper bound is pi over 4. Now for the computation of volume, that is, now you have to put here area and dx. For each point between lower bound and upper bound, x is chosen here, then you have to provide the area. For this one, now if you look at from side, then it will make a washer, so that that will make a circle, that will make a circle, so that washer will be made. Okay, for that one, this one is coming from that one. That is now sec x, right? That is a sec x. And for this large one, this is now 2 cosine x, right? Here, from here. So the a over x is the same as pi r squared and pi large capital R squared, so that 2 cosine x squared minus pi little r squared, so the sec squared x, right? Okay, so by using this one, the volume will be here now, pi will can go out, and then minus pi over 4 to pi over 4, that's 4 cosine squared x minus now sec squared x dx, right? Okay, for that one, for this one, you can use half angle formula. So the for whole this one, that is same as now twice of, okay, that is 1 plus your cosine 2x, right? Okay, so its antiderivative is the same as now that is from this one that is 2x, and from this one now plus sine and 2x, right? Okay, and for sec squared, it'll be here tangent of x. Now you are evaluating from minus pi over 4 to pi over 4, right? Then you can get the final answer. Okay, here the solution will be pi squared. Okay, or here we forgot putting pi in front of here now, right? Okay. Use integration by parts to find the integral. And here, for this one, we have only one term, but integration by parts is given in this way. Integral u of v prime is same as u v minus and integral u prime of v, right? That is the integration by parts. So here, derivative of arctangent is easily gotten, so that must be u portion. Now only one, but another can be here now number one. So the number one can be considered as now v prime. Then the given integral is same as uv, and integral of 1 is x, so that x arctangent of x minus integral. Now here u prime v, u prime is 1 over 1 plus x squared, and now v is x, and dx. Okay, so here that is x times arctangent of x minus, okay, if it is 2x, then that is exactly logarithm 1 plus x squared. So we put here 2 and divide by 2, so half, and logarithm 1 plus x squared plus c. Right? That's now part A. Now let's go to part B. For higher order of a polynomial like that, you can use a tic-tac-toe technique. Okay, let's try to do that. Here, u equal now x to the 4, and v equal now here sine x. For this column, we are putting derivatives, and for this column, we are trying to put integration, antiderivative. Okay, for that one, now 4x cubed and 12x squared and 24x and now 24, and eventually it will be 0. Okay, for that one, antiderivative of sine x is minus cosine x. Its antiderivative is minus sine x, and its antiderivative is now cosine x. And we'll use this one along with that multiplication, this multiplication, that multiplication, again here and again here, like that. So later on, because it's 0, now we stop here. Now antiderivative of that one is now sine x, and antiderivative of that one is minus cosine x, right? Now for that one is positively used, and that is now negatively, and along with positive and negative and positive, right? So we multiply in this way. So the answer is now, multiplication is minus x to the 4, now cosine x, and from second one, this is now plus 12x squared sine x, and this minus and minus will be cancelled out, and that one, and third one will make now positive, and okay, here, oh boy, that must be, okay, sorry about that one, that must be, okay, not this one, okay, that one is 4, okay, that's 4 x squared, now sine, right, or x cubed, 4x cubed sine, and then there's 12 x squared and cosine x, right? And here the fourth term must be that one, and negative, okay, negative, here the multiplication is here now 24x and sine x, right? Now the final one is same as here, okay, along with that negation, it will become negative, and then here there is 24 cosine x, right? So that's the antiderivative, and for this one, if you want, then you can combine the cosine terms and here the sine terms, okay? Okay, we'll go to number 4. Find the average value of the function f is sine x over 1 minus sine x between minus pi over 4 to pi over 4. Okay, for that one, here average value f, now average value is the same as, now the interval length is here, 1 over interval length is pi over 2. And then integral, minus pi over 4 to pi over 4 and f of x. So it's a sine x divided by 1 minus now the sine of x dx. So we have to solve this integral. Now for the integrand f here, f can be written in this way. If we try to multiply 1 plus sine x, okay, rather than that, first we change in this way, okay. So sine x and minus 1 plus 1 first, like that, and then 1 minus sine x, right? Then that will make minus 1, and then plus here 1 over 1 minus sine x. Yet we have a problem, so we'll try to multiply 1 plus sine x top and bottom. Then that will be minus 1, and that is 1 plus, okay, here plus, and 1 plus sine x, and bottom is 1 minus sine squared x, so that will be now cosine squared x. Okay, so that is same as minus 1, and 1 over cosine squared x is the same as, okay, that is sec squared x, and then now that one is, we can rewrite in this way, that is cosine and power minus 2, and then sine x, right? So we can find its antiderivative here, that is minus x, and that is now tangent to x. Now for this one is, okay, that is now power minus 1 of cosine x with here negation. Okay, so that first the integral, we try to find the integral. So the integral minus pi over 4 to pi over 4, and now there's f and dx. That is same as, okay, antiderivative of that one is now x minus x here. And then for that one, now this is a tangent of x. For that one here, minus, and here cosine x here minus 1. So if you make a derivative for that one, minus 1 will go out, and the power will change it into minus 2, and its derivative is now minus sine x. Okay, so we have to put here now positive. Okay, so along with that, from minus pi over 4 to pi over 4, then you can get the solution. Okay, and this integral is measured, and then now here divided by pi over 2, then you can get the average value here. You can check it easily. That is same as 4 pi minus 1. Okay. Now number 5, use trigonometric substitution to evaluate the integral. Okay, now inside radical, this 1 minus x squared cannot be negative, so that, and here we may try to make a substitution here, x equal now sine theta, then here dx is same as cosine theta and d theta. So we got that one, and also this can be replaced with sine theta, and for this bottom, now here 1 minus x squared and 5 over 4, 5 over 2, that is same as, okay, 1 minus sine squared theta, which is cosine squared theta, and power 5 over 4, 5 over 2. Okay, So that is same as cosine to the 5 theta. Okay. Now x is 0. Then here x is 0 means theta must be 0. Now x is 1 over square root of 2. Then now theta must be here pi over 4. Right? So the given integral is now integral from 0 to pi over 4. X is now sine theta, and the bottom must be cosine and fifth order and theta, and dx is the same as cosine theta d theta. Right? So that is now, along with it, 1 cancelled, and bottom is now cosine fourth power. Okay. So that is now from this one, we can rewrite this in this way, from 0 to pi over 4. Okay. Now sine theta and 1 here cosine theta. Let's try to separate in this way. That is cosine fourth power, so that 1 over now cosine third power theta. Right? Okay, and the theta. That is same as now integral from 0 to pi over 4, and this is tangent theta. That is a sec third power theta, so that there is a sec third power theta and times tangent theta, the theta. Right? Now, sec and tangent are multiplied with some powers. Then you can do change of variable, and either u equal sec theta or u equal tangent theta. For this one, now this part can be separated this way. That is now sec squared theta times now sec theta and tangent theta. Then if you substitute sec theta with u, then now that is du. Right? Du will be the sec derivative is sec and tangent and d theta, right? So that here we are using now u equal sec theta. Then du will be sec theta and tangent to theta and d theta. So this portion along with this d theta will be du. Okay, now sec theta is u squared. Now, okay, so the given integral can be changed into in this way. Once now theta is 0, then sec theta will be 1, and once theta is pi over 4, then now cosine theta is 1 over square root of 2. Its reciprocal is square root of 2. And that is now, okay, this portion is u squared and du, right? So that here that is 1/3 of u cubed n from 1 to square root of 2. So you will get this value, okay? Now, number 6, use the method of partial fractions to evaluate the integral. Okay, in here, now this one, bottom is has degree 4 and top has degree 3, so it is a proper fraction. So we can now transform the fraction into partial fractions. Okay, the manner is, now for this integrand, here for this linear factor, we have to have here now a over x, and because power 2, we have to put another one like that. And for x squared plus 1, here bottom is x squared plus 1, and top for quadratic factor, you have to get here linear, right? So now we have to decide a, b, c, d. Okay, now first we combine them. Now common denominator must be x squared and x squared plus 1. Now from the first one, that will be here a times x and x squared plus 1. From the second one, now there is b times here x squared plus 1. From the last one, now there is here x squared, so that cx plus d, and we have to multiply x squared, right? Now we have to sort from decreasing order of x. Okay, now here that same bottom, and for the top, for x cubed, okay, we'll try to get the coefficients of x cubed. That is, now we have here x, okay, a, okay, from this one we have a. Now x cubed is appearing now here, that is c, a plus c, that x cubed. And then how about x squared? We'll have x squared none here. We have here b, and from the last one we'll have d. Okay, x squared. How about x term, coefficients of x? From here we have x, from second one none, and for the last one none. Okay, there's x. How about the constant? Okay, none here. Okay, we have a b here from the second one, and for the last one none. Okay, so we got it. Now that must be same as that, which means a plus c must be 3. Now second one, b plus d must be 2, and a must be 1, and b must be again 1, right? Okay, already we decided a, b. From this one, now c must be 2, and from this second equation, d must be 1. Okay, here we decided, and a is now for this one, here there is 1, and for b there is now again 1, and cx plus d must be here, there is 2x plus 1, right? Okay, so from this one, now if we rewrite the integrand in this way, then we can see the antiderivative more easily. Okay, that is 1 over x. The second one is 1 over x squared. And then for the third one, now let's try to separate into two terms. That is 2x and x squared plus 1. And for the last one, now 1 over here x squared plus 1. Okay, the antiderivative of these terms are just from the first one it is logarithm x, and from the second one, okay, there's a minus 1 over x, right? And from the third one, now the top is derivative of the bottom, so the same as a logarithm of absolute value of x squared plus 1, but these are always positive, so that we don't need to put absolute sign, x squared plus 1. And for the last one, there must be arc tangent of x, right? And along with integration constant, that will be the final answer. Okay. Okay, that's the end of the review. Thank you.